I haven't brought up this issue of engagement just by coincidence. All of the talks today talked about this evasive concept of engagement. And when you think about it, what does engagement mean for a business intelligence conference that cares about industry and the connection between people? So if you're a production company, having your customers engaged means that they're loyal to your brand, that they keep on buying your product, and that they're happy. But there's a flip side to this engagement. It also means that your employees, the people who produce these products, are happy. They're motivated. They are productive. They don't get bored. They don't lag off. They don't look at their emails during work time or cat videos on YouTube. They're committed towards providing content that the company is selling. And I'm really excited by a particular type within this space of production companies that is called peer production systems. And they're amazing. If you think about it, we're all members of these organic systems. Anyone here has not visited Stack Overflow? It's an amazing online peer production system. It's free with a capital F, meaning it doesn't cost to participate. It's democratic. A high school student can contribute information that serves me, my students, and others. And they're really dependent on the motivation and voluntary efforts of the different participants. So Stack Overflow is an example. Wikipedia is a wonderful example. And even sites that on the top of it may not appear to be peer production are, in my eyes, a broad definition of peer production. So for example, e-learning systems, think about it. What they produce is knowledge. You have lots of students. What drives the students' interaction within the space of the system is their own self-motivation and will to learn. And the output is knowledge. So this is a great concept, and I'm super excited about these peer production systems. One of my favorite is called Galaxy Zoo, and it's a citizen science effort that allows volunteers to help classify galaxies that we receive from the Hubble Space Telescope. And the level of granularity of these galaxies that are taken by the telescope are relatively bad, and there does not exist an OCR algorithm that is able to decipher them. So they really rely on the power of volunteers to be able to make sense of these celestial galaxies. And with minimal overhead of training, I'm already able to become a human classifier and help science understand which of these galaxies this particular picture is. And there are thousands like me that help science understand this particular picture. And we can use statistics and other aggregate measures to understand what the correct answer is. So that's a great way of achieving a product that, in this case, helps science. And e-learning, this is just one example of a company that I work with called Matifik. It's an Israeli company that has raised hundreds of millions of dollars in the high-tech industry. And their idea is to rely on self-motivated users to learn central and essential math skills for K-12. That means Bet Sefer Yesodi. And my student Chaviv here has a wonderful poster about understanding student engagement within these systems. So these peer production systems are plentiful, they're ubiquitous, and they're important. And they're also a huge business. I'm just showing you the numbers for the e-learning market. But if you think about it, eventually sites like Wikipedia are going to start to bringing in advertisements, and you can only imagine the amount of revenue that these sites will begin to cover. I mean, you saw Guy's talk earlier today, which showed you how predominant Wikipedia is within search. So big business, but also a huge problem. What you're looking at here, I'll start with the one on the left. How do I get the laser here? Is this great? You're looking at the histogram of contributions that participants have on the Galaxy Zoo website. So on the x-axis is the tasks per user, and on the y-axis is the number of users. And as you can see, it follows a long-tail distribution. That is, most users classify a relatively small amount of galaxies before they stop and they drop off from the site, while only a very small number of users stick around and solve huge number of galaxies. And this is a phenomena that we see again and again within these voluntary-based peer production sites. So this is the histogram for the Matifik website. As you can see, there's the same phenomenon, even more skewed, of people dropping off from the system. And that's where the AI in my lab comes in. So we were approached by these websites, and they were looking for a real-world solution to a real-world problem. And we came up with this idea of using intervention as a mean of guiding participants' interaction and hopefully getting them to stay on in the website just a little bit longer. I mean, think about it. If all I do is shift this histogram just a little bit to the right, think of the amount of throughput that I'm able to provide to citizen science. But the problem is that intervention is a huge space. I mean, what does it mean to intervene and kind of nudge people in a good direction on these websites? Well, I have to decide how to target a population, how to form the intervention. Should it be a message or a sound clip? Or maybe it should be content, like finding galaxies that are interesting and that correlate with high motivation, or avoid galaxies that are sink. You know, they're so hard and maybe frustrating that people who encounter them leave. So there's a kind of a trade-off about how to form this intervention. And for the purpose of this talk, I'm going to describe work done by my collaborators, Eric Horvitz and Ece Kamar at Microsoft, and my student Avi Segal, which took this very large problem space and reduced it to understanding when someone is about to disengage from one of these peer production websites. By disengage, I mean dropping off, never to return to the system. We're going to try to predict that using features. And then, based on those features, we're going to decide whether or not to produce a message with some content aimed at providing additional motivation and encouragement for the user. So that's the purpose of this particular talk. So I mentioned disengagement. We used a machine learning predictive algorithm that receives as input a live feed of the traffic in Zooniverse. So after a process of negotiation with the Zooniverse admins, we were able to build what we call the incentive server. And this is one of the main points that I want to talk to you about today. It's a live server that lives in the Ben Gurion farm in the Ben Gurion department. And it receives as input all of the clickstream data that comes from the Galaxy Zoo website I talked about earlier. So this clickstream data isn't very rich. We don't have demographic information about the users. All we have is their click rate and their IP. So you can see here, this is some guy from New Zealand. And this is a live server. And the intervention server, for every click it receives from the Galaxy Zoo website, is trying to predict whether the aforementioned user is about to leave within a certain threshold. I'm not talking about what the threshold is. There's a trade-off, of course, as you can imagine, about choosing the best possible threshold to get a good predictive outcome. Those details are in the paper, and you're welcome to talk to me about that offline. So we have this online predictive algorithm that's helping me understand, hey, is someone about to lose motivation and leave your system? And based on that ability to build the supervised learning, I'm about to suggest 3 ways of intervening and generating a message that will hopefully inject some motivation into a user that is about to drop out. So one of the messages that we looked at emphasized the individual's own benefit or success in the system. So this message says, please don't stop just yet. And it was generated in the context of Galaxy Zoo. It kind of pats the person's ego. You've been extremely helpful so far. Your votes are really helping us to understand deep mysteries about the galaxies. Okay? We came up with that kind of message by looking into the social science literature that talked about how to keep people active within these self-determinated online systems. So we call this message helpful because it addresses the person's benefit from an individual perspective. We also had a message called community, which addressed the community aspect of the user. So this user is part of a big community of thousands and thousands of other classifiers that are helping to advance science. And maybe we need to come up with a message that reflects that aspect of the user's role. So if you think about it, these are different aspects of the user's role that I care about. And lastly, and this was the most interesting message I thought that message type that we were uncovering, some users apparently leave the system because they're afraid of making mistakes. That makes them lose motivation. So we were also able to create a message type that kind of triggers, that helps calm a person down and tell him, it's okay, we have so many other people that are providing clicks and contributions to this system. If you get this galaxy wrong, we still have many others that we can rely on. Okay, so I talked to you about 3 types of messages, and can I take an educated guess from the audience about whether these messages would work, and so to speak, which one of them would work? Any guesses? So people are saying the first one. I was extremely skeptical. I thought neither of these messages would work. And am I affected by an email message or by a pesky clicky on the screen, clippy on the screen trying to convince me to stay on a particular website? No. Why would I be affected by these messages? That was my initial thought. So to carry out a real testing of these different intervention strategies, we had a careful negotiation with the Zooniverse admins, and I can't specify enough how important it is to be able to have this negotiation process with the community that you're trying to interact with. For me as a researcher, it was a revelation to understand just how important the needs are of the different clients. So for example, they asked us, if you do an experiment in Galaxy Zoo, don't involve our super users, leave them alone. They're doing wonderfully without your intervention. Keep them out of the study, okay? And in addition, if you're injecting an intervention, also allow an opt-out option. So anyone receiving one of these messages while working online in the system should be able to opt out of the experiment. And in addition, they also asked us only to interrupt a person once during a session. And I should say that the vast majority of people on the Galaxy Zoo website never return after a single session. So really, it's an all-or-nothing decision that a computer needs to make about whether to intervene in order to keep a person happy and productive in the system. So we built this idea of using those messages and the machine learning predictor as a tool to conduct a study. What's great about the intervention server I talked about is that it is able to support studies run in different contexts. This is the way it would look like for a user on the Zooniverse side. So if I'm starting to classify a galaxy, I might be prompted by this slider that promotes one of the messages that I talked about. How do we find out which is the best message? Well, we did an alpha beta testing where we had 7 different groups. We had a control group that we called no intervention, which is simply the default way that people use the site. Then we had 3 active groups that received messages at random times. So for every participant in the Galaxy Zoo website, we sampled from the long-tail distribution that I talked about earlier, a particular time on the x-axis during which we prompted the message. And then we also had 3 active groups that presented the intervention message intelligently. That is, they weren't presented at random, but rather when the machine learning predictor told us that the participant was about to leave beyond a certain threshold that we set in an empirical fashion. Okay? So I talked about 7 different groups. What we did is for a certain amount of time, we randomly associated people on the Zooniverse website to one of these groups, and we took great care to balance out the number of interventions generated and the number of users in each of these groups. So we have an equal playing field with which to compare the performance of the intervention strategy for the different conditions. So after running the study, we found some really interesting results. First of all, only one of the messages worked, and your intuition was right on. It was the message that emphasized the individual contribution of the user. Only this group, active group that generated the helpful message when the intelligent prediction told us the person was about to leave, was able to significantly outperform all of the other groups. And just to understand why this is so interesting, if you take the same message, the helpful message, but generate it in a random fashion, then you're not going to get an effect. So it isn't enough to understand what to say, but also when to say it in order to promote contribution within the website. And when I mean promote contribution, I mean that the group that received the intelligent intervention not only stayed longer on the website, but also they were as productive as before. So we weren't hindering their performance and getting them to stay longer. And when you think about it, this is quite impressive, right? Because engagement is a psychological phenomenon. I have no idea about what it is that is making these people tick. I'm not a psychologist. But what I am able to do, even with this very rough clickstream data, is to understand when they're about to leave. And although the predictor isn't perfect, there's enough correlation between the predictor and whether or not people actually leave. So I'm able to get an effect. And we were very happy to see that this effect was also consistent over time. So as I mentioned, most people, 80%, about 80%, don't come back to the system after they log on to a first session. But for those who do and are able to receive additional interventions, our effect was indeed consistent, and they were able to stay longer as long as they generate interventions in an intelligent way. So I told you just one aspect of a study that we're running on negotiation that had to do with the Galaxy Zoo website. My student Chaviv is doing his thesis work on a different website, that of Matifik, where the idea is how do we get these self-motivated students to stay longer within the website. And if you think about it, this idea of engagement within the website doesn't stop there. It's also important for organizations like universities and the Army to understand what is it that make our clients tick, how likely is a student to remain enrolled in classes based on his performance, how likely is a soldier to remain in his position based on aspects such as demographics and his past performance. All of these questions about engagement are really opening up, I think, a very important research direction. I can think of, for example, competitions about engagement prediction in different conferences. It's a wonderful, wonderful research area. And my hope is that you'll see this talk as a kind of a call to arms to the different research communities within the applied sciences to think about engagement as a key area of research. My hope is that something like the incentive server can provide an API so that the next time someone wants to run an engagement study, he doesn't have to start from scratch. He can use our insights, our algorithms, our strategies to go there. And if you found what I said very interesting, I urge you to seek me out and talk to me about your interests. My lab is hiring as well. So thank you very much.
Any questions?
What you did is a 2x3 full factorial experiment with data, repeated data, that could be analyzed with MANOVA. And if you get into this statistics, you'll be able to do much more intricate experimentations. And the methodology is there. I mean, it's just up for grab. You don't have to develop anything. It's not research. It's just application.
So thank you very much. That's a wonderful comment. Yeah.
Okay, so thank you very much, Kobi Gal.